This is my trigonometry course. Today we're going to learn more complicated trigonometric equations. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In previous classes, we solved basic trigonometric equations like so. I gave you a ratio and asked you to find the corresponding angles. But today, like I said, we're going to learn more complicated trigonometric equations. So this is a trigonometric equation because we have a trig function, and we're going to start off with just basic equations here. So first thing we need to do is isolate the trigonometric expression. So we're going to subtract 1 from both sides, and you can do these steps. There's 2 steps to isolate. You can do them at the same time if you want, but I'm just going to go slow here. So we subtracted 1 from both sides and divided both sides by root 2. And now you can see that this is a very familiar ratio. You might recognize that as x over x root 2. That's a 45, 45, 90 triangle. And the ratio is negative 1 over root 2. Now sine is defined to be the opposite side of the reference angle divided by the hypotenuse. So that means that the opposite side has to be negative because the hypotenuse is always positive. So that means we have a triangle in the third quadrant and a triangle in the fourth quadrant. So we have to find this angle and this angle. Those are the 2 angles that we're looking for that are between 0 and 360. We're looking for the answers between 0 and 360. Now again, because this is a 45, 45, 90 triangle, we know that the reference angle is 45. So it's kind of hard to fit in there, but I'm going to draw a green 45-degree angle. And just using basic mathematics, we know that the 2 angles we're looking for are 225. You add 180 and 45 to get 225, and over here you subtract 45 from 360 and you get 315. So this is all review. Now if this seems new to you, then there's something wrong. That means that you didn't do the homework in the previous classes, or you didn't watch the videos. So this should be very familiar to you. The 2 answers are 225 degrees and 315 degrees. Those are the 2 angle measures that you can plug into this equation so that it works. Now be aware, again, there's an infinite number of solutions for this equation. There's negative angle measures, there's positive angle measures, but we're told specifically only to find the angle measures between 0 and 360 degrees. And in this case it includes 0 degrees. Okay, so let's go on to the next problem. We'll do a few more of these before you try one on your own. We're going to isolate the trigonometric function, so we're going to add 3 to both sides. And then we're going to multiply both sides by 4. And when cotangent or tangent are 0, or when sine or cosine are 0, 1, or negative 1, or when cosecant or secant are 1 or negative 1, you have the situation where the triangles are collapsed. And in those situations, it's very difficult to think of the geometry that corresponds to that situation. So it's better to look at these curves when we graph out these trigonometric functions. we can see the patterns. So we want to know when cotangent is 0. So that means we're looking for all the points on this red curve whose y values are 0. And we can see that 90 degrees and 270 degrees and negative 90 and negative 270 fit that description. And so we look for those corresponding angle measures, which I just mentioned. Now notice it says find all values of omega. So let's write 90 and 270. Well, let's just look at the pattern. So from 90 to 270 is or the difference between them is 180 degrees, and the difference between these two is 180 degrees, and the difference between these two is 180 degrees. So it looks like we can just add multiples of 180 to 90, and it turns out that that's the best way to describe that situation. So omega is equal to 90 degrees plus multiples of 180. Now again, this is just review from what we did in previous classes. So if this is completely unfamiliar to you, then that means that, again, you need to go back to the previous classes and review that information. Remember, we need to say n is any integer. And that is the answer. So if you want, you can plug in values of n and make sure we did that correctly. Plug in 0 for n, we get 90. Plug in 1 for n and we get 270. Plug in negative 1 for n and we get negative 90, and you can see that it works. If you come up with your equation and it doesn't work, that's okay. You can just modify it slightly. Alright, so let's try number 3. We'll do a couple more of these before you try one on your own. In this problem, we have trigonometric functions on both sides of the equation, but that's okay. We're just going to put those together on one side of the equation. So I'm going to subtract 2 root 3 secant a from both sides of the equation. And I get 5 root 3 secant a minus 8 is equal to 2. So again, I subtracted this expression from both sides of the equation. And so I had 7 root 3 secant a minus 2 root 3 secant a is equal to 5 root 3 secant a. Then I'm going to add 8 to both sides. And I'm going to divide both sides by 5 root 3. And maybe I should show that just to be clear what we're doing. So we end up with secant a is equal to, and let's reduce this, so 10 over 5 is equal to 2, so we can say 2 over root 3. Now normally you would take this expression and try to rationalize the denominator. Whenever you have a root in the denominator, that's considered an irrational denominator. But in this case, it's actually better to leave it in that form. So you may recognize this as 2x over x root 3. That's a 30, 60, 90 degree triangle. And secant is the hypotenuse divided by the side adjacent, the reference angle. Now the hypotenuse is always positive, so that's not going to really affect the sign. So the adjacent side in this case must be positive, because in order to get a positive ratio, the adjacent side must be positive, because the hypotenuse is always positive. So that means that we're in the first quadrant, or we're in the fourth quadrant. Because in these situations, the adjacent side of the triangle is positive. And again, the green hypotenuse is always positive. So secant is the green divided by the blue. You need those to be positive when you divide them. So the reference angle, again, this is a 30, 60, 90 degree triangle, but the big question we need to ask is the reference angle 30 or is it 60? Well, the hypotenuse is 2x, and the adjacent side is x root 3, because again, this is hypotenuse over adjacent. And the reason that I'm writing x's is because we don't really know exactly how big the triangle is. When you divide these sides, you get 2 over root 3 because the x's cancel out, so the x's will disappear, but I just want to illustrate that we don't know the exact we don't know the exact lengths of the sides. So of course this missing side is x. We know that just because we know the relations between the sides in a 30, 60, 90 triangle, and this side of course is negative x, but we don't really need to know that these sides are x and negative x. Now remember, the angle that is opposite x is always 30 degrees. So that gives us our reference angle. And that's really all we need to find the answers at this point. So one answer is the first quadrant answer. A is equal to 30 degrees, and the second answer is the fourth quadrant answer. That angle would be whatever 360 minus 30 is, and that is 30 degrees. So those are our answers. We're supposed to find the measures that are between 0 and 360 that work in that equation. So let's do one more of these. This is a problem that's going to require a calculator. And after doing this problem, you can try one on your own. Let's put a divider here. So again, we have trigonometric functions on both sides of the equation, and we need to combine those on one side of the equation. So I'm going to add 4 tangent beta to both sides of the equation, and I get 7 tangent beta on the left side of the equation. And then I'm going to add 2 to both sides of the equation. You really don't have to show every one of these steps. You're at a level where you can really do most of these steps in your head. So now we have a ratio that is, we don't recognize it. So that means that we're going to have to use a calculator. Now I'd prefer that you use a graphing calculator if you have one. If you have a graphing calculator, beta, well, in both situations, when you're using an iPhone or a graphing calculator, beta is going to be equal to tangent inverse of 5 over 7. That's what you enter into the calculator if you're using a graphing calculator. If you're using an iPhone, you need to enter 5 divided by 7 and then the equal button, and then you're going to push the second button in the upper left and the tangent -1 button. Do not push the tangent h -1. You're going to push the tangent -1 button. That means tangent inverse. And the calculator tells us that the answer is 35.5 degrees. We can just round off to 35.5. But it asks us to find all of the angle measures that satisfy the equation between 0 and 360 degrees. This is only one of the answers. There's actually going to be 2 of them. So how do we find the other answers? Well, we use this angle, which just happens to be the reference angle because it's an acute angle. and we consider the situations where tangent is positive, and a tangent is defined to be the opposite side of the reference angle divided by the side adjacent to the reference angle. And if the ratio is positive, then that's gonna be a triangle in the first quadrant and the third quadrant. Because here you have a positive divided by a positive is a positive, and over here you have a negative divided by a negative is a positive. In the other quadrants, you're going to get negative 5/7, a negative ratio. So the calculator gave us the reference angle. In fact, it gave us one of the answers. It's the first quadrant answer, so we don't really have to consider that situation. I guess I can keep it there. We need to do some basic math to figure out what this orange angle is. But of course, you know how to do that. We just need to add that number to 180 degrees. So that orange angle is 215.5 degrees. So beta is approximately equal to 35.5 degrees and 215.5 degrees. The problem doesn't tell us what to round off to. So we can just determine the accuracy ourselves. So those are some basic trigonometric equations, more complicated than the equations that we did in previous classes. I want you to take a picture of these problems with your phone, and you're going to use them to do the next problems. So use numbers 1 through 4 to help you do number 5. And when you come back, we'll do it together. Okay, we're back. So we're going to isolate the trigonometric function. So we're going to subtract 4 from both sides of the equation. And we're left with 5 cosecant alpha is equal to 5 root 2. And then we're going to divide both sides by 5. And we end up with root 2. And you may recall, or you may recognize that as x root 2 over x. That's a 45, 45, 90 triangle. So we don't need a calculator. So cosecant is the hypotenuse over the opposite side. The hypotenuse is always positive, so that means the opposite side must be positive also, but that gives us triangles in the first quadrant and the second quadrant. Now, the hypotenuse is x root 2, and the side opposite is x, as we explained. And the adjacent side must be x. Over here it's negative x. And this is a 45, 45, 90 triangle, so the reference angles are both 45 degrees. So one of our solutions is 45 degrees. That's the first quadrant solution. And the other solution is this solution here. And we find that by subtracting 45 from 180, and we get 135 degrees. So if you got that one right, excellent. So go ahead and try number 6. And when you come back, we'll do it together. Alright, we're back. So I'm going to add 9 root 3 to both sides. And we get negative 3 root 3 because negative 12 root 3 plus 9 root 3 is negative 3 root 3. You can think of it as negative 12 apples plus 9 apples is negative 3 apples. Not that you can really have a negative apple. Divide both sides by 3. And we get negative root 3. And you probably recognize this as negative x root 3 over x, which means this is going to be a 30, 60, 90 degree triangle. And it's negative root 3, so our triangles are going to be in the second quadrant and the fourth quadrant, because that's the opposite blue side of opposite side of the reference angle divided by the adjacent yellow side. So in the second and the fourth quadrants you get a negative number. So the reference angle, well, first of all, let's draw our relative sides. So we have the opposite side is x root 3 and the adjacent must be x, in this case negative x. And over here the opposite blue side is going to be negative x root 3, and this side is going to be positive x. And so we need to know the green reference angle. The angle opposite root 3 is always 60 degrees in a 30, 60, 90 triangle. So that angle is 60 degrees. This angle is 60. So 60 degrees is the reference angle, and this angle must be 180 minus 60, which is 120. And this angle must be all the way around like that. 360 minus 60 is 300 degrees. So those are the two solutions. Theta is equal to 120 and 300 degrees. But this problem tells us to find all of the solutions, not just the solutions between 0 and 360. So we need two equations. Theta is equal to 120 plus 360n and 300 plus 360n. But remember, when you have a tangent function, you have that special situation where you're skipping quadrants. So if you put these two together, you can see that the hypotenuses make a straight line. So what that means is you can just add 180 to get from one side, to get to from one quadrant to the other, the second quadrant to the fourth quadrant, then add another 180 to get from the fourth quadrant to the second quadrant, or you can go in the opposite direction. So we actually don't need two formulas. We can just choose one of those angles. I'll choose the smaller one, and we can just add multiples of 180. Of course, n is any integer. So if you got that one right, excellent. So go ahead and try number 7, and when you come back, we'll do it together. Okay, we're back. So we're going to add 14 secant b to both sides, and that gives us 8 secant b. Then we're going to add 7 to both sides. Then we're going to divide both sides by 8. So we get secant b is equal to 1. And then of course we have to go to our secant curve, because this is a situation where the triangle is going to be collapsed. So look at our secant curve. Find the points where the y values are equal to 1. And that's of course here and here. So 0 and 360 degrees. Now notice here that it says less than but not equal to 360. Your answer can be between 0 and 360 and equal to 0 but not equal to 360. So there's actually only one answer that they're asking for, and that is 0 degrees. I know that's kind of strange, but that's the answer to that problem. So for number 8, I want you to be aware that this is one of the situations where your calculator is not going to give you the reference angle. When cosine or secant is equal to a negative number, your calculator will not give you the reference angle. You'll have to use the number that your calculator gives you to find the reference angle. Go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. I'm going to subtract 4 cosine omega from both sides. And I'm going to subtract 2 from both sides. And then I'm going to divide both sides by 4. And we don't recognize this ratio. So we're going to have to use the calculator. And what do we enter into the calculator? We enter in this. If you're using a graphing calculator, you can just enter that exact expression with that exact order of symbols there. But if you're using an iPhone, you have to enter 3/4 and then be sure to push your plus and minus symbol at the upper right, the second button, and then press the cosine button, and I get 138.59. So again, that is not the reference angle. That is one of the solutions, but it's not the reference angle. So if cosine is a negative number, that means that our solutions are going to be in the second quadrant. We just found that solution. That's 138. But we're also going to have a solution in the third quadrant. So we need to find that purple. We're only looking for the solutions between 0 and 360. So we need to find the purple, but before we do that, we have to find the green reference angle. In order to do that, we just subtract 138.59 from 180, and we get 41.4. So that's 41.4 degrees. Now we just add 41.4 degrees to 180. And how do I know to do this? Well, we've already gone over this. This is just basic geometry. And it's based on our knowledge of trigonometry and reference angles and the basic geometry of angles that we learned in previous classes in this course, and also my geometry course. So the two solutions are 138.59 and 221.4 degrees. So if you got that answer, excellent. So now we're going to jump into some much more complicated equations, and we're going to use the fundamental identities that we learned, the trigonometric identities, and also we're going to need factorization to solve a lot of these problems. So it's going to get much more complicated pretty quickly here. So it says here, find all values of theta, and we see sine theta is equal to cosecant theta. Well, we don't know what to do here. We've never seen this before. How in the world are we going to solve this equation? The biggest problem that I see here is that we have two different trigonometric functions. We had problems over here where we had the same trigonometric function and we could combine to one, but we don't have that situation with this problem. So what do? In order to simplify the equation, we use, again, the basic trigonometric identities. I'm going to use a reciprocal identity and change that to 1 over sine theta. So that was a reciprocal identity. But that's not enough to really solve the problem, because now we have introduced a fraction into the equation. So now it seems even more difficult. But if we multiply both sides of the equation by sine theta, we can get rid of that fraction and things will start to become clearer. So sine theta times sine theta is sine squared theta. And here you get sine theta over sine theta, which is just 1. So that's why we multiplied both sides of the equation by sine theta to get rid of that fraction. This, believe it or not, is a much simpler equation to solve. In the previous problems, we were trying to isolate the trigonometric function. Well, we're close to doing that. We've isolated sine squared theta. Now we just need to square root both sides of the equation. And remember, whenever you square root both sides of an equation, you need to write plus or minus. That's one of the most common mistakes that students make, is not writing a plus or minus symbol. So now we have sine theta is equal to plus or minus 1. So that's going to be a collapsed triangle situation when sine is 1, -1, or 0. And remember, it's best to consult your sine curve when you have collapsed triangles. So that equation is asking us to find all the points on the red sine curve whose y values are 1 or -1. So that's obviously here, here, and here. And the problem is asking for all of the solutions. So we have 90, 270, and 450. 90, 270, 450, and -90, and so on and so forth. So let's write some of those numbers down. We don't know exactly how to write this. So let's think about this. 90, 270, I saw -90, and also we had 450. So we have to write equations somehow, and it looks like the solutions, again, these are the solutions. It looks like the solutions are all 180 degrees apart. So 180 degrees, 180 degrees, 180 degrees. So we can start from any number and just add multiples of 180 degrees. So you can start from any number. 90 would probably be best, and we'll just add multiples of 180 degrees. And you can check your curve to make sure that that works. So that's the answer. Okay, so we use the reciprocal identity. And let's do another problem like that, where we're using the reciprocal identity. Now again, we have two different trigonometric functions, and the equation is too complicated when you have two different functions. So let's change cotangent to 1 over tangent. Again, that is a reciprocal identity. and we can just write that as 3 over tangent A. You don't have to show that extra step if you don't want to. And now I'm going to multiply both sides of the equation by tangent A, because we've introduced a fraction into this equation, and we don't generally like fractions. So the tangent A's are going to cancel out, and we get 3 is equal to tangent squared A. So believe it or not, this equation is a lot easier to deal with. And again, these tangent A's cancel out. If you multiply, you'll get 3 tangent A over tangent A. The tangent A's have to cancel out. So now we're going to square root both sides of the equation. And remember, when you square root both sides of an equation, the most common mistake students make, or one of the most common mistakes, is they forget to write a plus or minus symbol. And so we have plus or minus root 3 is equal to tangent A. And we recognize that as x root 3 over x, or plus or minus x root 3 over x. So it's a special triangle. We don't need a calculator. And in this situation, all of the quadrants are going to have solutions, because we not only have positive root 3, we have negative root 3. So we have triangles in every single quadrant. I'm going to use this set of axes for the first and third quadrant, and this set for the second and fourth quadrant. So we have to know the reference angle. So tangent is opposite over adjacent, which means that this side must be x root 3, because the reference angle is always this green angle between the terminal side of the angle in question and the x-axis. And this side must be x, and of course this side is 2x, and the same is true for every one of those triangles. So what is the reference angle? Well, the side opposite, or the angle opposite x root 3 is always going to be 60 degrees. We learned that in previous classes. So the reference angle is 60, and every single one of these triangles produces a solution to that equation. So A is equal to 60 degrees, the first quadrant solution, 120 degrees, the second quadrant solution, 240 degrees, the third quadrant solution, and 300 degrees, the fourth quadrant solution. So again, 60 is one solution, 120 is another solution, 240 is another solution, and 300 is another solution. Okay, so let's try a couple more of these. Again, we're using reciprocal identities to help us solve these problems. It says solve if b is between 0 and 360, and we need to use a calculator. So this is going to be a calculator problem. So again, we're going to use a reciprocal identity. And there's a lot of different ways that you can solve these problems, so just be aware there's not just one method. But in this case, I'm going to multiply both sides of the equation by cosine b, and very important to use parentheses on the left side of the equation. You must use parentheses. If you don't, then your expression is going to be written incorrectly. In mathematics, you're not allowed to write incorrect expressions on paper. You will lose points if you do that in school. So now we're going to use the distribution property, and the reason I multiplied by cosine b is it's going to get rid of this fraction. We don't like fractions, as we explained in the previous problem. So I'm going to use the distribution property. I'm going to multiply cosine b times 1 over cosine b, and you don't really need to show this step, but if you do that, you get cosine b over cosine b. Then I'm going to multiply cosine b by negative 5 cosine b, and I get negative 5 cosine squared b, and 0 times cosine b is 0. Of course, this is just 1. And now we have an equation that's a lot easier to work with. We have one trigonometric function as opposed to 2, and we don't have any fractions. The only problem is we have a trigonometric function that is squared. So we're going to have to deal with that. So I'm going to subtract 1 from both sides and divide both sides by negative 5. And we get 1/5. So then I'm going to square root both sides, because again, we don't want to have to deal with cosine squared, and whenever you square root both sides of an equation, remember you have to write a plus or minus symbol. So we get cosine b is equal to plus or minus, and you can rationalize the denominator if you want to. It's not really important for this particular problem, but we don't recognize this ratio. We just don't recognize it, which means that you need to use a calculator. So b is going to be approximately equal to cosine inverse of root 5 over 5. That's one solution. Or b is going to be equal to cosine inverse of negative root 5 over 5. There's another solution. So there's actually going to be 4 solutions. So let's enter this into the calculator, and be careful when you enter it in. And we're going to find the angle. We get 63.43. If you get the wrong answer, that's okay. Just go back and figure out what you did wrong. You must enter the number in correctly to your calculator, or your calculator is going to give you obviously a wrong answer. Okay, so b is approximately equal to 63.43 degrees, and over here, let's see what that number would be. I get 116.565. So when cosine is positive, root 5 over 5, your solutions are going to be in the first quadrant and the fourth quadrant. So this is the solution in the first quadrant. To find the solution in the fourth quadrant, you subtract 63.43 from 360. We get 296.57. Again, these are the solutions if the ratio is positive. If the ratio is negative, as you see up here, then your solutions are in the second quadrant and the third quadrant. So the calculator already gave us the second quadrant solution, 116.565 degrees. If you want to find the third quadrant solution, then you add your reference angle, 63.43, to 180. So 180 plus 63.43 is equal to 243. So if we make this angle orange, that's 243.43. So those are the solutions. So we do have to check for extraneous solutions because secant can be undefined, but that only happens when we have quadrantal angles, meaning multiples of 90 degrees or possibly 0, but not in the case of secant. And of course these are not quadrantal angles, so we don't have to worry about extraneous solutions. Let's try another one of these problems. So again, if cotangent or tangent is undefined, when we plug in our answers we'll get extraneous solutions. Also, when cotangent is 0, we'll get an extraneous solution because we can't have 0 in the denominator. So unfortunately we do have to worry about extraneous solutions when dealing with trigonometric equations. But I'm going to use a reciprocal identity again. And 5 tangents minus 1 tangent is 4 tangents. And divide both sides by 4, and we get -1 is equal to tangent x. And you may recognize that as an x over x ratio, which means we have a 45, 45, 90 triangle. And because it's negative, it must be in the second quadrant and also the fourth quadrant, because the tangent is opposite, the blue opposite, over the yellow adjacent. So in both these situations, the opposite side of the reference angle and the adjacent side of the reference angle are opposite signs, different signs. So you're going to get a -1 when you divide them, but in the first and third quadrant they're the same sign, so when you divide you get a positive 1. So again, our reference angle is 45 degrees, so we can see pretty clearly one answer is 135 and the other answer is 315. So x is equal to those two angle measures, and we only want the answers between 0 and 360. Now we don't have any extraneous solutions because these angles are not going to give us an undefined cotangent or tangent value, and they're not going to give us 0 in the denominator here, so we don't have to worry about extraneous solutions. I want you to try number 13 now. You can use number 11 to help you. You want to convert cosecant omega to 1 over sine omega, and go ahead and try 13. When you come back, we'll do it together. Okay, we're back. So I'm going to rewrite cosecant omega as 1 over sine omega. So we used a reciprocal identity. And then I'm going to multiply both sides of the equation by sine omega to get rid of that fraction, make things a little easier to work with. And sine omega times 0 is 0. And we're going to have to use distribution. Sine omega times 1 over sine omega is 1. And 2 sine omega times sine omega is 2 sine omega squared. And then we're going to add 1 to both sides of the equation. You can do this in, you can show multiple, or you can do multiple steps in your head. You don't have to show every one of these steps, but I'm just going slow here. Divide both sides by 2, and now we have 1/2. That's sine squared, but we don't want sine squared. We want to simplify more, so I'm going to square root both sides of the equation. And remember, one of the most common mistakes that students make is they forget to write a plus or minus symbol when they square root both sides of an equation. So we get, I'm going to flip the equation around. I just prefer it to be that way. So now, remember, when you square root both sides of a fraction, or when you square root a fraction rather, you square root the numerator and divide by the square root of the denominator. So we get square root 1 over square root 2. The square root of 1 is just 1. And we recognize this as a 45, 45, 90 triangle. But because we have a plus or minus symbol, that means that we're going to have a solution in every quadrant. So I guess we don't really have to draw every possibility, but we know the reference angle is 45. So one of our solutions is going to be 45. Another solution is going to be 135. And 225 and 315. Now you could write an equation for each one of these scenarios, because we're looking for all values of omega that work in this equation. So we could have 4 different equations. Add 360 to 45, just keep adding multiples, and you get the first quadrant solutions. Add start with 135, add multiples of 360, and you get the second quadrant solutions. Start with 225 and keep adding 360, and you get the third quadrant solutions, and so on and so forth. So you could use 4 equations, and if you did that, that's okay, that's fine. But we can condense into 2 equations, because if you want to go, I'm going to rewrite those, it's kind of sloppy. If you want to go from the first quadrant solution to the third quadrant solution, all you have to do is add 180 degrees. So that's how we can condense to 2 equations. So one solution is going to be omega is equal to 45, and then we're going to add multiples of 180. So let me shrink this a little bit. So that is one of the equations that we need that represents this situation here. But we also have answers in the second quadrant and the fourth quadrant. But again, in order to get from the green angle to the pink angle, which is the next solution in the fourth quadrant, we just add 180 degrees. Is 180 degrees. So our next equation can be 135. We're going to start in the second quadrant and add multiples of 180. So again, if you wrote 4 equations, that's fine. But I would prefer that you write it in this way, because this is how you're going to see it in textbooks. But if you got 45 plus 360n and 135 plus 360n and 225 plus 360n and 315 plus 2 or 360n, then that's correct. So good job. Also, we need to be aware of extraneous solutions. If we plug in omega and we get an undefined number, or an undefined expression, that is, rather, then it's going to be an extraneous solution. But these are not angles that will give us an undefined expression, because these are not quadrantal angles. Only quadrantal angles will give us problems. So 0 degrees, 90, 180, so on and so forth. Okay, go ahead and try number 14. You can use number 9 and 10 to help you with 14, and when you come back, we'll do it together. Okay, we're back. So I'm going to change secant to 1 over cosine theta. And then I'm going to multiply both sides of the equation by cosine theta. And cosine theta times 1 over cosine theta is cosine theta over cosine theta, which is 1. And of course, we're going to square root both sides. Remember to write a plus or minus symbol when you square root both sides of an equation. And we get plus or minus 1 is equal to cosine theta. We're going to need to go to our cosine curve and ask which points have y values that are 1 or negative 1. It looks like here, here, and here. So 0, 180, and 360. So we have 3 solutions. So if you got that one right, good job. Now, some of these angles may be extraneous solutions, so when we plug in 0 degrees, do we get 0 in the denominator? And the answer is no. If we plug in 0, 180, or 360, we don't get 0 in the denominator, so we don't have to worry about that. Okay, go ahead and try number 15. You can use number 13 and number 11 to help you. And when you come back, we'll do it together. Okay, we're back. So I'm going to change cotangent to 1 over tangent alpha. That was a reciprocal identity. And then I'm going to multiply both sides of the equation by tangent alpha in order to get rid of that fraction and simplify the equation. So we get 0 is equal to 1 minus 4 tangent squared alpha. I'm going to subtract 1 from both sides of the equation and divide both sides by negative 4. And then we're going to square root both sides of the equation. And remember to write a plus or minus symbol. So we have tangent alpha is equal to plus or minus 1/2. Now how do we know that? Well, you can use this principle when you square root a fraction. You just square root the numerator and the denominator. You can also think about the logic. 1/2 times 1/2 is 1/4. So what number times itself is equal to 1/4? 1/2. Now this kind of looks familiar, but tangent, when it's equal to 1/2, this is actually going to be a calculator problem. So you were given that hint up here, use a calculator. So tangent alpha is going to be positive 1/2 or negative 1/2. And we need to use the calculator. So alpha is equal to tangent inverse 1/2. That's how you say that, tangent inverse. Or alpha is equal to, and that's not approximately, that's exactly equal to. It's equal to tangent inverse of negative 1/2 also. So now let's go to the calculator. This tells us that alpha is approximately equal to 26.565 degrees. And if we enter negative 1/2, then the calculator tells us negative 26.56 degrees. But the negative is obviously not going to be one of our answers. So let me shrink all this so we can get some more room. But these do give us the reference angles, and this is definitely one of our solutions. So the first quadrant solution is 26.57 degrees. I'm going to round off. And we also have a third quadrant solution when tangent is positive. Remember, it's positive. Tangent is positive in the first and the third quadrants. So 206.57 degrees. And we have the second quadrant solution, 153.43 degrees. And our fourth quadrant solution is going to be 333.43 degrees. So those are all the possible solutions between 0 and 360. So if you got those right, good job. Now, none of these angles are quadrantal angles. We don't have 0 or 90 or 180, 270, so we don't really need to worry about tangent being 0 or undefined. If tangent is 0 or undefined, then we have a problem. And if cotangent is 0 or undefined, we have a problem. But again, those we don't have those types of angles here. So if you got that one right, excellent. Go ahead and try number 16. You can use number 12 to help you. And when you come back, we'll do it together. Okay, we're back. So now I'm going to go backwards. I'm going to change 1 over secant beta to cosine beta. And if we add those up, we get 2 cosine beta. And if we divide both sides by 2, we get root 3 over 2. And there's 2 situations. We're looking for the answers between 0 and 360. There's 2 situations where cosine is positive. First quadrant and the fourth quadrant. And the adjacent side, cosine is adjacent over hypotenuse, so the adjacent side is going to be x root 3, which means the opposite side of the reference angle is going to be just x. So that means that the reference angle is actually 30 degrees. So one solution is actually 30 degrees. And the other solution is going to be this pink angle, which is going to be 330 degrees. And there you go. So if you got that one right, good. Now, again, we have to check to make sure we don't have 0 or something undefined. But again, that only happens when you have angles that are multiples of 90. So we don't have to worry about extraneous solutions. So if you got that one right, good job. Okay, so we used the reciprocal identities to help us solve trigonometric equations. And we didn't do a lot of factoring. In fact, we didn't do any factoring in those problems. But now we're going to need factoring when we use the ratio identities. So first, let's use a ratio identity because we have two different trigonometric functions in this equation. The equation is too complicated when we have two different functions. So I'm going to change tangent to sine y over cosine y. So that was a ratio identity. And then I'm going to rewrite, and I'm going to get rid of the fraction at this point. So I'm going to multiply both sides of the equation by cosine y. So the cosines cancel out, that's why we did that. And we end up with cosine y times sine y is equal to 2 times sine y. So in this situation, it doesn't really seem like we accomplished much. In fact, it doesn't seem like we accomplished anything at all. Our problem was that we had two different trigonometric functions, and now we still have two different trigonometric functions, but the situation is even more complicated because now we have three expressions, whereas over here we only had two expressions, 1, 2. So we didn't really accomplish anything at all. But this actually gives us a way to solve the problem. Up here we didn't really know what to do, but now we can use factoring. We're first going to move everything to the left side of the equation. So I'm going to subtract. I'm going to subtract 2 sine y from both sides of the equation. I'm going to move this over a little bit. So I'm subtracting 2 sine y from both sides of the equation. And over here, of course, I get 0. And it still may not be apparent why we're doing this. But now we're going to factor sine y. We're going to notice we have a sine y in each one of these terms. I'm going to factor the sine y, and whenever a teacher factors, students usually get angry because factoring is not done in this is just not something that is that you may recognize in your everyday math. So students, we do a lot of factoring in the curriculum, but not in this particular context. But the reason that we could do that is, well, in order to understand, just multiply sine y back into this difference, cosine y minus 2, using the distribution property. Sine y times cosine y is cosine y sine y, and sine y times negative 2 is negative 2 sine y. So we know we can go in the forward direction, so why not backwards? So the reason this helps us is it tells us that if you have some expression multiplied by another expression and you have 0, then that means that either this expression has to be 0 or this expression has to be 0, because when you multiply a number by 0, you get 0. So sine y is equal to 0, or cosine y minus 2 is equal to 0. So I know that that seems pretty complicated, and yes, you're correct. It is complicated. So over here, we're going to isolate cosine y, and this produces no solution. cosine y, when it's equal to 2, there is no solution. How do I know that? Well, if you look at the cosine curve, you can see that it's never equal. The cosine value is never equal to 2 because it only goes between 1 and -1. Cosine cannot be equal to something up here. The curve is not up here. So that equation gives us what we call, well, it doesn't give us any solution at all. So we can just say cosine y is not equal to 2. That's impossible. But here we're given a lot of solutions. So if you look at your sine curve, you'll see that well, we're trying to find all the values of y. So all the values where sine y is equal to 0, that's just going to be multiples of 180. Again, you can look at the sine curve to understand why that is. Okay, let's try another one of these. This is a situation where it's really not obvious what we need to do. If you've never seen an equation like this, we just don't know what to do. But we're going to use some tricks, some math tricks. We're going to take that cosine A and put it on the other side. And maybe I should show that just to be clear. I'm going to subtract cosine A from both sides. So I'm putting the cosine on the other side. And we get negative cosine A on the right side of the equation and root 3 sine A on the left side. And I'm then going to divide both sides of the equation by cosine A. Again, these are tricks that you have to know in order to solve these problems. So this is going to be equal to -1. And at this point, you can see we have a ratio identity. That's where the ratio identity comes in. Sine over cosine is equal to tangent A. So now we're going to divide both sides of the equation by root 3. And now you may recognize this as x over x root 3. That's a 30, 60, 90 degree triangle. So you have two situations where tangent is negative when you're in the second quadrant or the fourth quadrant. The opposite side of the reference angle is 1, or x, so that means the reference angle is 30 degrees. Again, this is all stuff that you should be fairly familiar with. So this angle is 150 and this angle is 330. So A is 150 degrees and 330 degrees. So was that pretty complicated? Yes. It's a fairly complicated equation. But some of these trigonometric equations do require some special methods to solve, and that's why we're learning this today. So I want you to try number 19. You can use number 17 to help you with number 19. And when you come back, we'll do it together. Okay, we're back. So I'm going to change cotangent to cosine theta over sine theta. That's a ratio identity. And then I'm going to multiply both sides of the equation by sine theta to get rid of the fraction. And I'm left with sine theta over cosine theta is equal to negative cosine theta. And then I'm going to add cosine theta to both sides. And what that's going to do is it's going to put everything on the left side of the equation. So now you see we have a cosine theta that is common to both these terms, so I'm going to factor that cosine theta out. And because we have a product that's equal to 0, that means one term in the product must be equal to 0, or the other term in the product must be equal to 0. And if we look at the cosine curve, we see that cosine is 0 at 90 degrees, and 270, actually not 270, it's 0 at, 270 degrees. Again, you can look at that curve to verify. Look at the cosine curve. And over here we have to solve for sine theta, and then we look at the sine curve and ask what are all the find all the points where the y value is -1, and then find the corresponding angle. And when you do that, you get 270 degrees for theta. So that's all the values between 0 and 360. But of course these are redundant. So we can just say that the two solutions are 90 degrees and 270 degrees. So if you got that right, that's very good. That was a difficult problem. So I want you to use number 18 to help you do number 20. And when you come back, we'll do it together. Okay, we're back. So again, it may not be exactly obvious what to do, and if you got stuck, that's okay. We're going to divide both sides of this equation by cosine b. And I have to remind you that there's actually more than one way to solve this equation, so if you tried a different method, that method might work. So now we recognize this as x over x. That's a special triangle, so we can find the solutions without a calculator. And the reference angle is 45, because this is a 45, 45, 90 triangle. And if tangent is positive 1, then the angle that we're looking for must be in the first quadrant or the third quadrant. So the first solution is 45 degrees. That's the first quadrant solution. And the second solution is the third quadrant solution. Again, we know the reference angle is 45, so add 45 to 180 and you get 225. But this problem is asking us for all of the solutions. So now this is another situation where you can write two equations. You can write 45 plus 360n and 225 plus 360n. That's correct. There's nothing wrong with that. If you wrote 45 plus 360 and 225 plus 360, that's correct. But I just want you to be aware that you're not going to see that answer in textbooks. The answer that you're going to see is 45 plus 180n. Why is that? Well, that's because if you write these two solutions on the same coordinate system, you see that in order to get from one solution to the next solution, you just add 180 degrees. And then if you want to go from the third quadrant to the first quadrant, you just add 180 degrees again. So you can add or subtract 180 degrees to go back and forth between the first and third quadrants. So I erased the coordinates, but there's the easiest way to write the solutions. So if you got that right, or something similar to that with 360n, good job. I do want you to write your solutions in this form, so please make sure you understand what we did there. Okay, so we've used the reciprocal identities and the ratio identities to solve equations. As you can see, these equations are getting pretty complicated. So now we're just going to use the Pythagorean identities with a few more problems here. Let's start off with an easy one. We know that cosecant squared beta is equal to 1 plus cotangent squared beta. Actually, I guess this problem is not that easy, but so we used a Pythagorean identity. Now we can subtract 1 from both sides. And then we're going to subtract cotangent beta from both sides. And I'm not going to show this because we're running out of time. And so now we're going to factor cotangent beta from both of those terms. And again, to understand why we can do that, use the distribution rule to multiply back. And you can see that we get back to here. So again, that's a lot of math. A lot of math is occurring there. And you might be thinking, well, how in the world am I supposed to know to do that? Well, the only way you'll know is with practice. You have to do a lot of these practice problems. These problems can get complicated. They can really get complicated. And you have to use a lot of different methods to solve them. So cotangent beta is equal to 0, or cotangent beta minus 1 must be equal to 0 in order for that equation to work. So if we solve this equation, we get cotangent beta is equal to 1. So this is a collapsed triangle. We want to know all the points on the cotangent curve where cotangent is equal to 0. And so we have 90, negative 90, negative 270, and all those points are 180 degrees apart. So it looks like we can start with 90 and just add 180n, multiples of 180. And we're looking for the solutions between 0 and 360. So it looks like we're just going to have 90 degrees and 270. And over here we have to use a special triangle. This is the same thing as x over x. So we have a triangle in the first quadrant and a triangle in the third quadrant. How do I know that? Because over here you have positive divided by a positive is a positive, and over here you have negative divided by a negative is a negative. So those are the two situations. So we know that this is a 45, 45, 90 triangle. The reference angles are 45. And so beta can be equal to 45 degrees or 225 degrees. So let's write all the solutions in ascending order: 45, 90, and the other two solutions. So I know that seems pretty complicated, and it is. But these problems do get fairly complicated. I can't protect you from more complicated equations forever. You're going to need to do some equations that require you to factor and use your identities. So try number 22. You can use 21 to help you. And remember to use your trigonometric identities. Secant squared is equal to something. You should have that right in front of you. Secant squared is equal to one of those Pythagorean identities. So try 22. When you come back, we'll do it together. Okay, we're back. So secant squared alpha is equal to tangent squared alpha plus 1. So we used a Pythagorean identity. Then I'm going to subtract tangent squared alpha from both sides. And then I'm going to subtract 1 from both sides. And this is a collapsed triangle situation, so if you look at your cosine curve, you see that we get -1 when alpha is equal to 200 and actually it's going to be 180 degrees. And we just want the solutions between 0 and 360, so that's the only solution. So again, you have to consult with the directions here. So that was a lot easier to solve that particular problem. So if you got that one right, good job. Okay, we have a couple more problems. So if we look at this equation, we see that there's pretty much no method that we've seen so far that we can use to solve this. And so we have to use a special method. We're going to use a trick. We're going to square both sides of the equation. And then we're going to use a Pythagorean identity to simplify this equation. So 1 squared is obviously 1, but one of the most common mistakes is thinking that this expression converts to sine squared theta plus cosine squared theta. This expression does not equal sine squared theta plus cosine squared theta. Instead, we have to use FOIL. What this means is sine theta plus cosine theta times sine theta plus cosine theta, and you can see pretty clearly that we need to use FOIL. So again, 1 squared is 1. And using FOIL, we were going to multiply the first terms, and we get sine squared theta, and then the outside terms. and then the inside terms. And then the last terms. So we use FOIL from here to here. And we're going to put the sine squared theta and the cosine squared theta next to each other. And we're also going to combine these terms because they're actually like terms. So we get 2 sine theta cosine theta. So those terms combine to this expression here. Remember, the commutative rule of multiplication means it doesn't really matter the order of the product. So now we're going to use a Pythagorean identity. Sine squared plus cosine squared is equal to 1. And then we're going to subtract 1 from both sides of the equation. And then we're going to divide both sides of the equation by 2, just to make it look simpler. And now we have a product of 2 trigonometric functions, and that product is equal to 0. So what that means is that sine theta must be 0 in order for the equation to work, or cosine theta must be 0. So these are situations where you have collapsed triangles. The angles are going to be quadrantal angles. So if you look at your sine curve, you see, and we need the solutions from 0 to 360 inclusive. So we see that when sine is 0, theta is 0 degrees, 180 degrees, and 360 degrees. And when cosine is 0, we have 90 degrees and 270 degrees. But there's a problem. It turns out that some of these solutions might be extraneous solutions, because whenever you square both sides of an equation, you have to be careful that you don't produce extraneous solutions. So what we have to do is take these solutions that are between 0 and 360 and plug them in. Looks like all of our solutions are multiples of 90, 0 and multiples of 90. So let's try plugging in 0, and this may take a while. You need your sine curve and your cosine curve, but if you plug in 0 degrees, sine is 0, and cosine is 1. So 0 plus 1 is 1. So 0 degrees works. So we're going to keep that one. And let's try 90 degrees. Sine 90 is 1, and cosine 90 is 0. So 1 plus 0 is 1. So that works. I'm going to write these down so I don't forget. So theta is 0 degrees and 90 degrees. Those definitely work. Now let's try 180. Sine 180 is 0, and cosine 180 is -1. That didn't work. 0 plus -1 is not 1. So that's an extraneous solution. So I'm going to go ahead and write the extraneous solutions too, just so we can know what happened to them. So theta is not equal to 180 degrees. What about 270? Sine 270 is -1, and cosine 270 is 0. So -1 plus 0, that doesn't work. So 270 is also an extraneous solution. And what about 360? Our last solution is 360. Sine 360 is 0, and cosine 360 is 1. So that actually works. 0 plus 1 is 1. So we have 3 actual solutions and 2 extraneous solutions. So again, you have to look for those extraneous solutions. I know that's kind of intimidating to have to use that special technique and also look for extraneous solutions. So try number 24. You're going to use the same technique. You're going to square both sides of the equation. And when you come back, we'll do it together. All right, we're back. So again, we're going to use that special technique to square both sides of the equation and use the Pythagorean identities. So we get cosine omega minus sine omega times cosine omega minus sine omega is equal to 1. And then we're going to use FOIL, multiply the first terms, the outside terms, the inside terms, and the last terms. So now we're going to collect sine squared omega and cosine squared omega, and we're going to combine those like terms. So I just want to be clear that all these terms here condensed to that. And now we're going to use a Pythagorean identity. Subtract 1 from both sides. Divide both sides by -2. And you can see that we get the same situation. We have sine times cosine, so we're going to have the same exact solutions. So what we can do is just copy all of these solutions. Now we don't know exactly which ones are extraneous and which ones are real solutions, but I'm just copying this so I don't have to rewrite all that stuff. Okay, so now we have to figure out which solutions are extraneous and which are not. So now 0 and 360 are they can't be part of our solutions because we have less than symbols, not less than or equal to, so we don't have to check 0. So let's check 90. Cosine 90 is 0 and sine 90 is 1, so we have 0 minus 1 is -1, so 90 does not work. Let's check 180. Cosine 180 is -1 and sine 180 is 0, so -1 minus 0 is -1. That doesn't work. Let's try 270. Cosine 270 is 0. And sine 270 is -1, so 0 minus -1 is +1, so that actually works. So it looks like 270 is the only solution to this this equation in that interval. So theta is equal to 270 degrees. And we have a lot of extraneous solutions, but we don't have to, I guess we can list them. So theta is not equal to 90 or 180. So if you got that right, good. If you had a few problems there, that's okay. Now you have a better idea of how to handle that type of problem. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and screenshot number 2 and number 3 and number 4 number 5 and number 6. But don't go before you get your homework. Remember, the homework is required. It's not an option. So here's the first screenshot of the homework. Be sure to get the homework done completely correctly and neatly. Here's the second screenshot of the homework. And don't go before you get the answers. Remember, it's not enough just to attempt the homework. It must be done correctly. So here's the answers. Get that homework done completely and correctly. And I'll look forward to seeing you in the next class.